This video is for the 2022 AP Calculus AB or BC free response question number 1. I've got it here in front of me. I've got several devices running, so hopefully this won't be terribly awkward. But it is a calculator problem. The rate at which vehicles arrive at a certain toll plaza is given by this function here, where T is the number of hours after 5 a.m. and A of T is measured in vehicles per hour, just making it really clear that it is a rate. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting. Hopefully you can see the calculator that I bring up. I have already typed this function into my y equals, and I am already in radian mode. I have changed my window because this is only valid from 5 a.m. to 10 a.m., which is time 0 to 5. And just knowing that it's 450 times the square root of a trig function, I estimated that, it would go up to 450. I just like to go a little bit beyond. And you can see this graph right here, which is always positive. So when I get to that A part, what it's asking us to write in an integral expression that gives a total number of vehicles, we don't need any absolute value around it. And also, they didn't used to do this, kind of like that they do it now. They make it really clear that 6 a.m. is time 1 and 10 a.m. is time 5. And that's A of T. You don't actually have to write out the function there. That would be sufficient to earn the 1 point that the A part is worth. It must be a definite integral. It must have a lower and an upper bound. If you put it in absolute value, it's okay, because the absolute value of A of T, because this function always has positive outputs, is equivalent to this, okay? So if you put it in absolute value, that's fine. You're also allowed to, write the actual function in there. I don't recommend it, because if you make any one error in doing that, type write 45 instead of 450, you would lose that point. And it's a really easy point to earn. If it's missing dt, or if you accidentally put dx, because that's what we commonly use, you can still earn this point. All right, so let's move on to another part. B. Find the average value of the rate. Sorry, the cat jumped up in my lap. And no, it's not my cat. So why is it in my house? Okay, B. Find the average value of the rate. Now, it's not asking for the average rate of change. It is actually asking for the average value. So we have a formula for that, and it is the average value of the rate of change from 6 to 10. So that's 1 over 5 minus 1, the integral from 1 to 5 of A of T dt. You could compute this with your calculator, so I'm not going to spend time doing that. 375.536966. And you can round that. You don't have to. You can actually show all the decimals if you want to, but those are the decimals that they have shown in the scoring rubric, and they have 375.537 or 375.536. That means that they allow you to truncate or round when they don't tell you what to do. And they also put the units on the end, vehicles per hour, because it is still a number of vehicles per hour, just because it's got that average value constant in the front. It is 1 point for using the form of an average value, the 1 over b minus a integral from a to b, blah, 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 f of x dx. And then 1 point for having the answer. So that's 2 points total for that part. All right, C is the rate at which vehicles are entering the plaza at one excuse me. So, all right, is the is the rate at which vehicles arrive at the toll plaza at 6 a.m. time one increasing or decreasing? Is the rate increasing or decreasing? And this is something I always struggle with. Am I supposed to find A of 1 or am I supposed to find A prime of 1? And I just said it in such a way that you should know the rate at which is the rate increasing or decreasing. This is the one that I need right here. Hopefully my calculator is showing up here when I do this. Let me get out of that. So just how to do that again. I want the derivative of what I have in my y equals. So I'm going to go with math 8 for numerical derivative. Oh dear. Okay, I'm going to put x. I'm going to put what's in my y1 here. And then we're going to plug in 1. So it's going to give me a value about 148. So A prime of 1 is about 148.9472727. Wow, 7272. Okay, I got it. And you know, these are their words. I always like to show you their words because A prime of 1 is greater than 0. The rate at which the vehicles arrive, just writing that complete sentence, at the toll plaza is increasing. So 1.4 considers this. If there's work that you found that value, 1 point for the answer with reasoning. So my reasoning, of course, is in this statement because A prime of 1 is positive, it's going to be increasing. So that was 2 points. So we're up to 5, which means that there are a whopping 4 points for part D. And D is that part, you know, as I've told you before, where they're going to do something that kind of mixes things up and makes you think. A line forms at the toll plaza whenever A of t is greater than or equal to 400. The number of vehicles in line for 0 t between A and 4 is given by, and they give you the function here. Whereas A is a time when a line first begins to form to the nearest whole number from the greatest number of vehicles in line at the toll plaza. They're asking for a maximum and justify your answer. So the candidates test is going to come into play here. So let me come down here. Unfortunately, I can't have that question in front of me, but I happen to have paper of the same thing, so I'm able to look at it. So this, and we have to figure out what A is, unfortunately. So what I would do is I would want to know, you know, because I've already got in my y equals, I've already got the function A of x. I'm also going to graph y equals 400. I want to see when they actually equal each other. So let me get that calculator back out. Like I said, I didn't test it in advance. I don't know if you're actually able to view this on my screen or not. But I'm going to graph these two together, and I see that it intersects twice. And so it's like this and here, and now I need to find those 2 points. And I'm going to go to calculate. I'm going to select intersect. I'm going to go to this first one over here, enter, and there it is. It's about 1.4693716. I think that is the A value that they're alluding to here. And what I'm going to do is I'm going to exit out of this, and see that number is actually stored as X right now, and I'm going to store that as A. Now I'm going back to the graph, and I'm going to find that other point of intersection. Be faster to scroll along a linear one, but I have to get closer to this point, and it's about 3.5977133, which I'm going to call B, in case I need that number, which I know I do. So since it is the last thing that I did on the calculator, X is now stored as that number, and I'm going to store that as B. Okay, so let me just hide that for a moment. So when I now think about this as a function, I'm going to tell you my reasoning and why I really didn't want to do the candidates test, but I have to. In terms of this integral here, it is an accumulator of area, and it is accumulating area as t gets larger till it gets here. And then after that, it's going to start accumulating negatives. So that's going to have to be my maximum right there. But in my opinion, though, I could probably write an explanation that would make sense. To me, it's just easier to justify this using the candidates test. So, well, you can see that I have these. If I make it clear that this number is A, I can use A in anything that I write with it. So I'm going to write n prime of t, because we're trying to find a maximum or minimum. You know, we've got to find our critical numbers, which is actually the work that I just did. Sorry, I didn't really explain it, did I? Is A of t minus 400, which is equal to 0 when A of t equals 400. Hence, that's why I wrote the equation the way that I did. I just didn't want to make it minus 400 and deal with it that way, but I could have. I could have changed my function in my calculator, but I liked my window already. So we have our two values that make that true. I'm going to round them here just because I have them shown to the right, and what I'm going to store them as. In fact, I'm going to write it right here as well, just to make it really clear. So since the easier justification, in my opinion, is to just do a candidates test, I'm going to have these two things. A is the beginning of time when I'm supposed to be considering this. I'm just going to write A, then I'm going to write B, and then I'm going to use 4. And really, each one of these is just a matter of, you know, plugging it into this function here. So I'm not going to bother to waste your time. The next one would have the integral from A to B, and the next one would have the integral from A to 4. So those numbers are 0 for this one, of course, 71.254, and some more change after that, 62.338. So it is clear that the maximum, the greatest number of vehicles, the greatest number, let me actually write it out, the greatest number of vehicles, they do want you to round to the nearest whole number, line is 71. 1.4 considers n prime of t equals 0. Don't forget to write that. 1 point for finding these two values here. 1 point for the answer, which is here. It's also shown here, right? And then 1 point for the justification. And once again, I gave a justification with the accumulation function, but that would just be really hard for me to write in a bunch of words. It would consume a lot of my time, and you know that you have to be as efficient as possible. The candidates test is just easier.